Assalamu alaikum warahmatullahi wabarakatuh. So I'll be using this to explain how to solve Bernoulli differential equation again. So please ensure you take notes and always revise by solving questions. This is how you master the steps. So I believe the challenge you are still facing is knowing which step to take. So the first thing we have to know is what is the general form of a Bernoulli equation before we can find the general solution or particular solution. So we have to identify how a Bernoulli equation looks like. So a Bernoulli equation will always look like this. You have a derivative of a function y, that's dy dx, also written as y prime, plus a function p. So there is a function p. P is a function on x as well. So let me write it as p subscript x. So this function p will be multiplying the function y itself, then equals to another function q of x multiplying y raised to power n, y raised to power n, such that n is not equals to 1, and in fact n starts from what, 2, 3, and so on. So this general form of a Bernoulli equation. So if you are given any differential equation, so you have to first note whether it is a linear DE or it is a Bernoulli differential equation. Because if it's linear, the power of y, with the highest power of y will 1. But this one, the highest power of y is not 1, it's more than 1. So that should give you an idea that, oh, I'm solving a Bernoulli differential equation. So let me solve an example to highlight the steps that you take for any Bernoulli differential equation. If you are given any Bernoulli DE, just follow all these steps that I'm about to use in solving this particular example. Okay, so I don't want to bother you too much with this what's it called. I will have solved the general steps first, then I'll now pick an example. But so I'll not bother, so I'll be using like 2 in 1. So I don't want to bother it so as to not be too long, so I can grab it faster. So let me pick a question. Let me pick a simple question so that it will be easier for you to comprehend. So let's say we want to solve this DE. So example now. So let's say we have to solve this DE, which is dy dx plus y equals to x y square. So when I look at this question, does it look like the general form that I wrote above here? Of course, it looks like it, because from general form there is a differential, there's a derivative of y, which is also here. Okay, then there is a function p, which is here as well, although it's not, is a, well, I say is a invisible, is there, that is 1. You know, there is invisible 1 here. So this 1 is like my p in the general form. Then there is y itself, a function y itself, then equals to another function q, which is this x we are seeing here, then y raised power n, y raised power n, which is this y raised power 2 here. So you see that it is a Bernoulli DE. So that's first thing you have to know. Identify what type of DE you are solving. So now that we have identified that it's a Bernoulli DE, the next thing we are going to do is we are going to use the how do I call it now? That substitution method, where we are going to substitute v equals to uh, v equals to y raised power 1 minus n. But before that, the first step you will do after you have identified the DE is that you divide the what's it called? You divide the question given to you by y raised power n. Okay, so that's the first step. Divide by what? Y raised power n, which in this case our y raised power n is the y raised power 2 for this particular question. Okay, so that means our n is equals to 2. Our n is 2. Our p is 1, and our q is x. Our q is x. Okay, so divide the equation by y raised power 2. So that's the first step you take for any DE. Divide the equation by y raised power n. So for this example, it is y raised power 2. So doing that, that will give me y prime divided by y raised power 2 plus 1y divided by y raised power 2 equals to xy square divided by what? Y raised power 2. So if I solve this, first this y square divides this y square, 1. So I'm okay with that one. Then I can use the law of indices on the left hand side, although you can leave it like that. Sorry for my voice, I'm having challenge with it. So you can leave the left answer like that, but it's always better if you can use the law of indices there. So this y square, that's the denominator, I can bring it up here. But the sign will change from +2 to -2. Remember that law of indices, that negative power law. Okay, so I can bring it up, so it will now be y raised power -2 times the y dx. So I've brought it up, then plus, so using the law of indices here as well, there's a power 1 here, there's 1 up here. So using the law of indices, this will be y raised power 1 minus 2, which is y raised power -1, y raised power -1, then equals to what? X. Okay, so this second equation, you can keep it, we need it later. Yes, I usually asterisk this part where I divided by y raised power n, as in the result of divided by y raised power n. I will asterisk it because I will need it later. Yes, because the aim of what we are doing so far is to make the Bernoulli look like what? A linear equation. Yes, I'm trying to linearize the Bernoulli equation. So to linearize it, I will need to come back here later. I will need to come back to this line to do some substitution. So I'll always asterisk so I can easily find it in my steps. So you asterisk, or you just label this particular part. That's after divided by y raised power n. Okay, you label that part exactly, and you keep it. Okay, so now that I'm done with them dividing by y raised power n, the next thing now is I will that's using substitution now. So using substitution method, so I will let another function, usually v. If you check most of your materials, you usually use v, but it's not composed, it's just a symbol. So I will let v be equals to y raised to power 1 minus n. That's the next step. Remember, our n is 2 in this case, so I'm just using 1 minus n to tell you that in case the power is not, the n is not 2, it could be 3, it could be 4. So use the same step. So which in this case, it means I'm letting v to be equals to what? Y raised power 1 minus 2. You know our n is 2. So that is 1 minus 2, which is minus 1. Okay, and that's what we have here already. You can see it here. So meaning later, when I want to substitute back, I will change this one here to v. Okay, but let's leave that for now. So let's continue from here. So v equals to what? Y raised power 1, and v is equal to y raised power minus 1 rather. Okay, so now that we have done this, the next thing is differentiate this function v. Now remember, this function v is also a function on x. Yes, v is a function on x, the same way y is a function on x. This y itself is a function on x. So if I want to differentiate v, differentiating v means differentiating function of a function. Okay, because y itself is a function on x, then you now put, there is now a power minus 1 on it, on that function y. So that is function of a function. So to differentiate v, you are going to use chain rule or function of a function. So which means that my dy dv rather dv dx, using that chain rule formula, is dv dy multiplied by dy dx. So this is the chain rule formula. So that's what I will use, and that's what you use as well for any question given to you. When you get to this stage, you have to use the chain rule. Okay, so using the chain rule is quite easy. So what I'm saying now is my dv dx, that's v prime. So let me use v prime to represent that. So my dv dx, which is v prime, is now dv dy. So dv dy means differentiate this part here the standard way that we used to differentiate. That's use the power to multiply the coefficients. Okay, then take away 1 from the power. So using that, so minus 1 times 1 is what? That's minus 1. Then y raised power, take away 1 from that power, which is minus 1 here, that will be what? Minus 2. So that's my dv dy. So my dv dy is minus y raised to power minus 2, then multiply by what? Dy dx, that's y prime. Okay, this is dy dx here, so I change it to what? Y prime here. So this is my dv dx. So from here now, I can do some substitution back. Yes, I can now do what? Substitution. I will substitute two things into that equation that I said I will come back to it. I will substitute two things. Okay, now the first thing I will substitute is this v. You know, I said v equals to what? Y raised power minus 1. So this one. Then the second thing I will substitute is this v prime, this v dx. Yes, so that's the second thing I will substitute. Now what do I mean by that? You go back to this place, the one that I asterisked, this one that I asterisked, this particular part here. So you see that there is y raised to power minus 1 here. So which means I will replace it with this v. Okay, so replace this y raised to power minus 1 with v. Is that clear now? Then you also see that there is y raised to power minus 2 times y prime here. That's y prime minus 2 multiplied by y prime. That's a dy dx. So I will replace that with minus v prime. So first, let me multiply this one by minus 1 so that it will resemble what I have there. So multiply this last line by minus 1. So I'll be having what now? Minus v prime equals to what? Y raised to power minus 2 times y prime. Okay, so I'll substitute this into that asterisk equation. So anywhere I see y raised to power minus 2 y prime, I will replace it with minus v prime. So doing that substitution now, so doing the substitution, so substitution into the what? Into the what's it called? The asterisk equation. So what will I have? So instead of this, it will be minus v prime, and instead of this, I'll be having what? V there. So what I have now is minus v prime plus v equals to what? Equals to x. Minus v prime plus v is equals to x. So this is my what? Linearized equation in v. So I've turned it to what? A linear equation in v. So which is one of the first aim of solving Bernoulli equation. The first thing you do is try to turn from Bernoulli to what? Linear. So then, to make it more standard, I can multiply by minus 1 so that that v prime will not have a coefficient of minus 1. So that's more standard. So multiply by minus 1 all through. So that should give us v prime minus v equals to what? Minus x. So this is so I can asterisk this one too, because I'll also need it later. So let me give it 2 asterisks. So let me give it 2 asterisks because I'll come back to it later as well. So now that we are at this stage, the next thing we have to do now is we try to solve this using integrating factor. Yes, solve this using integrating factor. Now what's integrating factor? So that's the next step. Find your what? Integrating factor. Find the what? Integrating factor. Integrating factor. So this integrating factor, we usually use the symbol mu to represent it. If you check most materials, mu is the symbol for integrating factor, and the integrating factor is given by e raised to power integration of p dx. Yes, it's given by e raised power integration of p dx. But this p now is the p when the equation now is in v. So that's why I like putting subscript v there. Yes, subscript v. So the p here now is not the p in the original equation. Okay, the p that I will use now is the p in this place here, the one that I studied 2 times, this one. Okay, and what's that p? That p is the coefficient of v, which is -1. You know, there's a visible 1 here, there's 1 there. So that p in the integrating factor is the coefficient of v, which is -1. So which means that my integrating factor now is what? Mu, which is equals to e raised to power integration of -1 dx. Okay, -1 dx. Now, so that's why you have to know how to integrate various integration techniques. So I believe you know how to integrate this already. That's integrating -1. Okay, and you know that if you are integrating a constant with respect to x, the answer is what? That constant times what? Times x. So if you integrate -1 dx, it will give you -1x. Okay, -1x. So that's why our integrating factor now is e raised to power -x. So that's my integrating factor. So the next step is you will now use the integrating factor to multiply this equation, this linearized equation in v. So use your integrating factor to multiply the linearized equation in v. Is that clear now? So I will do that now. So which means I'll be having e raised to power -x times v prime minus e raised to power -x times v equals to -x multiplied by what? E raised to power -x. So multiply everything by that integrating factor. So after doing that, we now try to solve this equation here. We try to solve it. Now, solving this, we have to also look at integration techniques. Okay, now this left hand side, the right hand side seems simple. I can integrate that one. Okay, this one is using what's it called, integration by part. But the left hand side here, this one, this left hand side, this part here, I want to integrate it. Okay, but before you integrate, look at it. Does it represent a differential of any function? This left hand side, before you put integration on it, don't be too quick to put integration sign on this side. Okay, although you can put it though, but first I want to look at it very well. From what I'm seeing here, I can see that this looks like what's it called, product rule. Yes, because this is a function, let's say function f multiplied by derivative of v, okay, minus, okay, or plus what, plus v now multiply by differentiation of f, because this minus e raised power minus x that you are seeing here is the differentiation of what? E raised power minus x. So this looks like what? Differentiation of what? Of the product of two functions. You go and check your techniques of differentiation, that product rule. So that means I can write this left hand side, okay, as differentiation with respect to x of what? E raised power minus x times v. Yes. So that left hand side is the same thing as differentiation of e raised power minus x times v. So I can now what? Integrate it. Okay. And remember, integration is the opposite of differentiation. So integrating the right hand side too, that's minus x raised to power what? E raised to power minus x. So integrating the left hand side, my integration will just take care of the differentiation. Okay, you know that if you integrate the differential of a function, it will give you the function back itself. Yes, if you integrate the derivative of a function, it gives the function back. So it's like saying this integration will take care of the differentiation. So I'm left with only the what? The function here. Is that clear now? So that means we are left with what? E raised power minus x times v on the left hand side of the equation. Then for the right hand side, I'm integrating the product of two functions, because this is one function multiplied by another function. Product of two functions. So which technique are we going to use here? This one will be what's it called? Integration by parts. Yes. So that means I have to integrate this right hand side using integration by parts. So I have to digress a bit. I don't want to assume that you know it. So let me just explain that one too. So I'll come back to this later. So let me digress. That's I want to integrate minus x multiplied by what? E raised power minus x dx. So to integrate this, okay, I will turn the question into integration of u dv, which is now equals to ultraviolet minus integration of visual display unit. You know, that's my own personal statement of remembering the formula for integration by parts. Yes, that's the way I remember my own. Okay, so you turn the question into what? Integration by part. This is the integration by part formula. That's integrating u dv is equals to uv minus integration of v du. Okay, so now the question now is, what's my u, what's my dv, what's my v, what's my du? It's very simple. Now from your question that you are trying to integrate from this place here, the one that I will call my u is which of this function can I differentiate easily. Yes, which of this function is easier to differentiate. So I know that this minus x for me will give me a simple differential. If I find the derivative, it's very simple. The answer is just minus 1, which is a very simple value. So I will say my u is equals to what? Minus x. So that from the formula, this u here, let it be equals to what? Minus x. Then you let what's it called now? The v Okay, you let your dv, you let it be equals to what? E raised power minus x. Okay, you let your dv be equals to what? E raised power minus x. So my u is minus x. Then immediately I can differentiate it to find the u. Differentiate that immediately. So what's the u? That's differentiate the u, find the u dx. So the u dx is what? That's a minus 1. That's, I'm differentiating this, minus 1. So which means my du is equals to what? Minus 1 dx. That's if you cross multiply. My du is what? Du is minus 1 dx, because I will need it here. So later I'll substitute this du for this. Okay, then next is you equate dv. Okay, your dv, this dv here in the formula will now be equals to what? E raised power minus x dx. Okay, so let's do that now. So dv is equals to e raised power minus x dx. If I divide both sides by dx, that means dv dx is equals to e raised power minus x. Okay, now integrate this time around. That's why I said the one that is easily integrated. So this time around you will integrate to get your v. So integrate both sides. So that I'm integrating dv dx equals to what? Integrating e raised power minus x. Okay, so integrating dv dx, what does that give us now? So if you integrate dv dx, you will get v. Yes, that will give us v. So I have v. So my v now is equals to what? Integration of e raised power minus x. And if you integrate e raised power minus x, you will get what? You will get minus 1 times e raised power minus x. This is from integration of exponential function. Hope you remember that. So that's why the prerequisite for this course is mastering your integration techniques. So that's my v. So now that I'm done with this, I will substitute all this into the integration by part formula, into this place here. Let me clean this. So u dv. So I'll substitute my u, my dv, everything. I'll substitute them back to this place. So what I'm solving now is what? So I'm solving integration of u dv as what? uv minus integration of v du. So what's my u that I said before? Let's scroll back up. U is minus x and v is minus e raised power minus x. So which means my uv will be what? Minus x times minus e raised power minus x. So that's my uv. So uv minus integration of v. V is what? this is my v here. So that's minus integration of what? Minus e raised power minus x times du. What's our du? We got the u first up here. So these are du here. Du is minus 1 dx. So times what? Times minus 1 dx. So doing that now, minus 1 times minus e, that's simplifying this first, that will give me plus e raised power minus x. So let's go further. Then simplifying this one too, this will give me x e raised power minus x minus integration of what? That should give us e raised power minus x dx. Okay, then let's go further. So that's now what? X times e raised power minus x minus integrate e raised power minus x. That will give us minus e raised power minus x. Okay, then plus what? Plus c, which is our constant of integration, plus c. Yes. So with this now, what do I have? Let me simplify further. So I have x times what? E raised power minus x plus e raised power minus x, e raised power minus x, then plus what? Plus c. So that's what I have now. So which means my, let's go back to that place. Remember, this is where we started from. Where is it? This line here. So I'm coming back to this line. Okay, I'm coming back to this line here. So that means e raised power minus xv is equals to the integration I just did now. So let me go back. So now we have so now we have that what? V times e raised power minus x, okay, equals to what? The results we got here, equals to x times e raised power minus x plus e raised power minus x plus c. Okay, so that's what we have. So solving for v, I will divide the equation by e raised power minus x. That's to solve for v. That's making v the subject. So doing that, I will have v equals to, if I divide everything, e raised power minus x, e raised power minus x, e raised power minus x, then also e raised power minus x. So if I do that, this divides this out. Okay, then that's 1. So that's 1 1. This also divide this 1 1. Okay, so what I will have now is that will be v is equals to x plus 1 v equals to x plus 1, okay, then plus what? Plus c over e raised power minus x. E raised power minus x. Then from the law of indices, this e raised power minus x, I can bring it up here. It will turn to e raised power x. So that means my v is equals to x plus 1 plus plus what? C times e raised power x. Yes. So you now substitute back. Remember, what we have to find is general solution for y, not v. So you recall that we said v equals to what? Y raised power minus 1. So substitute back now. So we do that now. So this v will now be y raised power minus 1. Y raised power minus 1 equals to x plus 1 plus c times e raised power x. So to solve for y, not y raised power minus 1. Remember, y raised power minus 1 is the same thing as 1 over y. So that means 1 over y equals to x plus 1 plus c times e raised power minus x. I can put over 1 here. Then take the reciprocal of both sides. Yes, that's turn both sides upside down. So therefore our y equals to what? 1 over x plus 1 plus c times what? E raised power x. And that is the general solution for the Bernoulli differential equation. So these are general solution. So that's the answer. So I try to be slow in my speech so that you can get it easily. So you can watch the video over and over again and jot as much as possible that you can. Then you to try questions on your own. Exactly. Now let me quickly add something. What now? This one is just general solution. What if you are asked to find the particular solution? Okay, because this one that we just solved here is general solution for many set of points. Now, particular solution means this constant of integration, you have to find it. Yes, this constant c here, you have to get it. But that one is possible if you are given initial value problem. Yes, let's say from the beginning of the question they say find the particular solution when y naught is equals to when y naught, let me pick a value, let's say y naught is equals to 2. For example, I just pick this value. So we call this initial value problem if you have to find particular solution now, not general solution. So they will give you an initial value. So this initial value here means x, you let your x, that's y naught means when x is 0, that's x is 0, then y at that point is 2. So meaning, go to this general equation, this general solution rather, anywhere you see x you put 0, anywhere you see y you put 2. Okay, so that means it will now be what? It will be 2, y is 2, so that's 2 equals to 1 over x is 0, that's 0 plus 1. Okay, 0 plus 1 plus c times e raised power 0, and e raised power 0 is 1. The e raised power x, and x is 0, so e raised power 0 is what? Is 1. So that's plus c, because c times 1 is still c, so let's just put c there. So then you now solve for this value of c, which if you solve it, c 2 is equals to 1 over 1 plus c. Okay, right? Yes. Then if you cross multiply, that is 2 plus 2c equals to 1. 2 plus 2c is equals to 1. So that means our c is equals to minus half. So c is minus half. So that means the particular solution now, okay, at that initial value. So instead of c here, you put minus half there. So the particular solution will be y equals to 1 over x plus 1, then plus what? Minus half e raised power x. So that one is at particular point where y naught is equals to what? 2. So I just have to add that in case you have been taught how to find particular solution. So like I said, watch this video over and over again to get the concept very well, and can use it for any differential Bernoulli DE. So if you try anyone and you are still unable to solve it, send it to me. I will explain that one to you again. So let's keep doing that till you get it very well. Okay, so try your best and always study. Like I say, always study. It helps. That's the only way you can master all these steps. When you study very well, you study regularly, that's the only way you can master it. Okay, all right, have a nice day.